Where do you see this being used?
So what I think there's a lot of different places where this can be used. One of my favorites is the education piece. I've had a lot of different, cybersecurity analysts or somebody that's working on their side project for whatever tech stack they're trying to do. And they just want to kind of mess with Elastic. They want to interact with it and test it out. I think the education component is a good use case. Customers that really want to just see how it looks in their environment, test it out. This is also another great use case for them because they don't want to spend, weeks trying to learn how to deploy the stack. They just want to see if the product's actually going to work. And this is a great way to get that going. And, as we're seeing it's building right now as we're talking, this is straightforward, simple. We're going to have an air gap set up here. And the only difference, if you actually did want to bring this into an air gapped environment, is we pull down the containers, we load that up onto like a CD or some other way to transfer that over to the other environment, and then we just load it up there and we're good to go. And it's just a small additional step to kind of build everything that we need to build.
You can run this. It will build the containers if they don't exist. So if you ran this on a laptop or some kind of internet connected service or computer that can pull down those containers, it will build the EAR and EPR containers for you. And then you can just take those images into an air-gapped environment.
So so then that makes sense. So that's the difference between air gap and not. Right now, you're grabbing the data from these containers from the internet, but as long as you had already grabbed them, put them on a CD, pointed this command to, like, if you had a Docker repository, basically, you just put it in the Docker repository and be able to grab them that way.
Yeah, you would load correct.
And I mean, we're waiting for the EPR, but this is it. That's the command, correct?
Yep. It's pretty robust. Once the EPR comes up, so right now, Kibana is just created. The only one that's up is the Elasticsearch node. The EPR will not, or Kibana will not come up until the EPR is loaded because Kibana has to load a bunch of plugins for Fleet, and it needs to know where to talk to get to it. So there's a delay. So now Kibana is coming up. Once Kibana is up, Fleet will be able to start coming up. So we've got it in order of operations to how these things come online.
If we have time, could you walk through each of these different volumes and containers? Like high level, what are we looking at? Why are they separated like this? What are we seeing?
Basically, just to be able to maintain data. In the Docker Compose, the ES cluster for certs, that volume is where all the self-signed certs are being generated and shared between all the clusters. And then this can persist data. If you're storing stuff in your demo, you don't lose it. It's just persisting the volume between Fleet and everything else, storing its logs and settings and things like that. So now it is up. So I'm going to switch windows here.
Yeah, show us what you got.
So this just comes up on localhost 5601. I get to figure out how to switch this. This is one of those post-process things.
And after we get through this step, we will walk through the code because for one of the use cases, as we were talking, one of the use cases is this is a great, get something up and running, get a pilot running, POC running. Don't have to worry about that timing. But when someone starts going into an enterprise prod type architecture, they'll want to make tweaks to this. And so I want to walk through the code to help us understand what you built so they can make minor tweaks, that they don't have to recreate the wheel. They can simply work with what you built.
Okay. So in the env file that the Docker Compose is using, you set the default username password. So it's just Elastic and change me. Super simple.
On localhost, I noticed.
Yep.
Which makes it even easier. Makes sense.
You're going to specify in the env file the external IP. It enables you to actually connect external Fleet agents to your host. So what we did in setting up AirGap, the easiest way to see where the changes are being made to it is in Fleet itself. So in Fleet, you can see we have the Fleet server set up. Inside this policy, we now have APM, our application performance monitoring, Docker, since we're running in Docker, so it's going to pull those logs. You have the fleet server, agent server, and the standard system one. But in our settings is where you'll start to see, so this is the local IP I'm setting in the env file. So it's telling fleet where to go find itself. And then you have your EAR that's set up down here, and that becomes the default. It's set as the default. So when you're installing agents or upgrading agents, it knows where to go to get those updates. The EPR, I don't know if I can see it in here, is set up, and in the log files, you'll see it reaching out to the EPR server to pull down all of these integrations. You still have access to all of the integrations with Elastic. You can install them, run them. If you want Elastic to plan, you can put that in. Everything is fully enabled. The env file I'm using has the trial license automatically enabled. It's just uncommenting out one field and commenting out another, changing one value. You have full use of everything in here. One of the things that we did within, and this is not part of the monitoring profile we set up, this is just default, the way it comes configured. Search and Kibana are pre-configured with APM. So you can immediately see what's going on in your cluster and how the cluster is performing. You can see what kind of data is passing through it. It's not something that I've seen normally pushed out in installs, but we wanted to do it just so that you can see what's going on behind the scenes with Elastic.
Yeah, and this is a really good for the education component too, because you can say, okay, when I actually interact with the dashboard in Kibana, what are all the subsequent calls that are happening, right? So you can get that deeper understanding of not just how you interact with the product, but how the product interacts with itself.
Yeah, you can see the actual transactions, ones you actually did in that demo you just showed.
Yep.
And the time it's spent in each of those transactions. So, yeah.
And then since we did the monitoring, what the monitoring profile is doing is setting up a metric beat in a container and monitoring the Elastic cluster that you just set up. So if you go to stack monitoring, it will be pre-configured to show you everything that's going on. Your nodes, latency, what's going on, the percentage of utilization, disk space free, how the nodes are configured, the standard data you would expect to be able to see.
Yeah, love it. Yeah, so it's definitely healthy. It's running 3-node cluster. Your env file helps you describe if you want to separate things on different IP addresses. Yeah, it's working. It's definitely working. Before we walk off of this demo, any other things you want to share before we start looking at the code?
Frank?
Not really. The self-monitoring is kind of a nice to have, definitely. You really have everything at your fingertips here, which is nice. And we saw it took just a couple minutes to get up and running. And this is fully, your environment. So no, I don't think I have anything else to add here. It's a classic cluster.
Since we do have this running on Docker and we did install the Docker integration, you immediately will have a Docker dashboard to show you also why which stack is running.
Makes sense. See actual images right there.
Yep. The data is being passed in, so you are ingesting data. There are...
You're building your own pilot with your own data.
Yeah. We just put it up and we already have 800 up. So, or 800 logs.